Opaque, hard-coded routing logic in your enterprise AI infrastructure is silently draining corporate budgets right now. Let's examine how unchecked agent interactions trigger catastrophic, cascading API token execution failures across networks. Modern enterprise software deployment requires absolute architectural visibility to remain viable. When autonomous systems communicate without strict guardrails, standard operational models break down completely, creating unprecedented challenges for corporate engineering infrastructure teams. Unmonitored agent interactions introduce severe multi-tenant vulnerabilities. These systemic failures manifest as infinite loop overheads, leaking vital memory assets and exhausting corporate cloud compute resources rapidly. When multiple autonomous nodes invoke external model endpoints simultaneously, coordination decay happens immediately. Without a centralized orchestration layer, enterprise data layers experience severe performance degradation and highly unpredictable system state mutations. Traditional enterprise architectures simply cannot manage the erratic concurrency profiles of advanced agentic applications. Traditional middleware solutions lack the required granular context tracking to prevent semantic drift and downstream model execution bottlenecks. The problem intensifies when application engineers hard-code deterministic pathing directly into individual agent configurations. This practice creates brittle dependencies that always fail spectacularly under unexpected or non-deterministic real-world production inputs. Let's analyze the hidden costs associated with these uncoordinated multi-agent systems. Token consumption patterns become completely exponential, inflating your external operational cloud service expenses without delivering any measurable business value. To resolve these critical systemic vulnerabilities, enterprises must fundamentally pivot their design patterns. The solution lies in deploying robust, stateful, event-driven orchestration gateways across all internal and external network perimeters. These specialized gateways leverage centralized microservice coordination frameworks to manage agent communication paths. By decoupling routing logic from individual model weights, we achieve unprecedented structural control over compound AI systems. Implementing deterministic state chart checks ensures that every agent state transition remains completely verifiable. This mathematical validation eliminates the risk of infinite loops by enforcing immutable execution boundaries at runtime. Let's explore the underlying technology that enables this scalable architectural pattern. By incorporating standardized communication protocols like the Anthropic Model Context Protocol, we build highly secure, stateless tool-calling communication channels. These open standard interfaces connect autonomous hosts directly with centralized production databases. This structural design, highlighted within the Enterprise Tech Brief Master A5 database.pdf, ensures absolute data provenance and precise access control across complex systems. Furthermore, integrating semantic web standards and advanced knowledge graph schemas improves entity resolution. Decoupling core business logic from internal model weights creates a highly modular and easily modifiable corporate infrastructure. Let's dissect the specific mechanisms preventing memory fragmentation in high-throughput environments. Utilizing advanced memory management algorithms like paged attention optimizes the utilization of graphic processing unit memory pools under heavy enterprise workloads. This optimized allocation strategy completely eliminates key-value cache fragmentation bottlenecks during multi-tenant operations. Consequently, your system maintains consistent sub-second latency profiles even when handling hundreds of concurrent agent requests. Security remains a primary pillar of this scalable gateway architecture. By enforcing strict runtime constraints, we directly mitigate the prominent security vulnerabilities identified in the official OWASP Top 10 matrix. Specifically, The orchestration layer acts as an immutable shield against dangerous indirect prompt injections. Every incoming payload undergoes rigorous data sanitization before reaching downstream internal language model production execution clusters. Additionally, the gateway establishes rigid boundaries for external tool execution parameters. No agent can initiate arbitrary system commands or unauthorized database mutations without passing a stringent multi-factor cryptographic authorization check. Let's turn our attention to the profound economic impacts of this architectural paradigm shift. By systematically optimizing agent routing paths, corporations compress their external API call expenses by 45%. This massive fiscal optimization directly enhances overall infrastructure efficiency, maximizing returns on technology investments. Capital can then be reallocated toward training proprietary foundational models on highly curated internal corporate datasets. The implications for the corporate labor force are equally transformative and far-reaching. Application engineers transition from writing manual, repetitive, brittle routing code to becoming high-velocity, strategic agent lifecycle directors. These professional developers focus entirely on designing complex state charts and monitoring ecosystem health. This shift elevates the engineering discipline, driving rapid innovation and higher developer velocity across the entire organization. To successfully implement this advanced framework, a structured deployment roadmap is absolutely essential. Enterprises must avoid rushing complex multi-agent architectures directly into production environments without thorough localized critical validation loops. The first deployment stage requires building isolated localized monitoring loops for individual agent clusters. This approach allows infrastructure teams to track context drift and identify early runtime degradation patterns safely. During this initial validation phase, engineers establish rigorous baseline metrics for token utilization efficiency. These reference points are vital for configuring accurate anomaly detection thresholds before scaling the architecture outward. Once localized loops demonstrate consistent stability, we transition to a distributed production mesh architecture. This containerized microservice framework, governed by cloud-native computing foundation standards, provides horizontal auto-scaling capabilities. The production mesh leverages advanced service discovery mechanics to manage agent communications dynamically. If a specific agent node fails, the orchestration gateway automatically reroutes the transaction to a healthy container instance. Crucially, explicit task isolation guarantees total system resiliency under heavy user concurrency profiles. By isolating execution threads, the gateway prevents a localized failure from cascading into a global infrastructure outage. Let's analyze how this isolation pattern safeguards shared data structures. When an agent executes a complex workflow, its scratchpad memory remains strictly confined to its assigned runtime environment. This design choice completely prevents cross-tenant data contamination, upholding the strict compliance standards mandated by global security frameworks. It ensures that sensitive enterprise assets remain thoroughly protected at all times. To further optimize system performance, the gateway incorporates dynamic semantic caching layers. Frequently requested information is stored in high-performance vector databases, minimizing the need for repetitive, costly model inferences. This semantic retrieval process relies on precise entity relationship mappings to control model outputs tightly. By utilizing structured graph databases, we significantly decrease hallucination percentages across all operational production agent workflows. Let's consider the operational monitoring requirements for a mature production gateway deployment. Infrastructure teams must maintain real-time visibility into system error budgets and containerized service performance orchestration metrics. By deploying sub-second monitoring solutions, engineers can intercept anomalous token consumption patterns immediately. This proactive stance ensures that malicious exploitation or runaway execution loops are neutralized before impacting corporate budgets. The architectural governance models must remain completely auditable. Every routing decision, state transition, and tool invocation must be logged to an immutable, secure, centralized data registry. This high-fidelity audit trail is indispensable for regulatory compliance and deep forensic analysis. It allows security teams to reconstruct complex multi-agent interactions during post-incident investigations with absolute precision. As enterprise AI continues to mature rapidly, the underlying communication protocols will evolve accordingly. Building gateways using open, cross-platform runtimes ensures that your core strategic infrastructure remains entirely future-proof. Compiled neural graphs can execute natively across variable hardware topologies without requiring driver modifications. This abstract execution layer protects your long-term capital investments in specialized hardware accelerators and cloud resources. Let's synthesize the primary technical takeaways from this comprehensive architectural analysis. Stateful orchestration gateways resolve the critical core vulnerabilities of hard-coded routing logic by providing deterministic runtime enforcement mechanisms. By centralizing microservice coordination and enforcing strict state chart checks, enterprises achieve absolute control over agentic workflows. This approach eliminates cascading failures, memory leaks, and unpredictable token spend across networks. The economic advantages are immediately measurable, delivering an impressive 45% compression in external API expenses. This structural efficiency directly enhances corporate profitability while scaling AI initiatives across the enterprise. Simultaneously, the labor transformation elevates your engineering workforce into strategic lifecycle directors. Developers shift their focus to higher-value design tasks, driving sustainable innovation and technical domain mastery throughout the company. Implementing this scalable model requires a highly disciplined, phased approach to deployment. By prioritizing localized monitoring loops before expanding to production meshes, infrastructure teams minimize risk and guarantee operational stability. Finally, explicit task isolation ensures that your system remains completely resilient under intense user concurrency. This core design principle protects shared resources and maintains consistent, high-performance service delivery metrics globally. As we look toward the future of automated enterprise operations, stateful orchestration will remain the definitive foundation. Organizations that master these design patterns will successfully lead their respective industries. Let's address the integration of legacy enterprise resource planning platforms with these modern orchestration gateways. Connecting legacy architectures to agentic systems requires robust, containerized middleware to ensure smooth data translation. The gateway acts as an abstraction layer, translating complex asynchronous event streams into synchronous transactional formats. This capability prevents legacy back-end systems from being overwhelmed by high-velocity agentic API requests. Furthermore, deploying the gateway within a hybrid cloud environment optimizes both security and performance. Sensitive data processing occurs within private on-premises servers, while scalable inferencing workloads leverage elastic cloud resources. Identity federation models must connect directly to the orchestration gateway to guarantee secure access control. Every agent token must be explicitly tied to a verified user session identity across systems. This integration prevents privilege escalation vulnerabilities, ensuring that agents operate strictly within authorized data perimeters. Maintaining rigid identity boundaries is a fundamental requirement for achieving complete zero-trust architectural compliance. Let's review the technical implementation of state charts within the orchestration gateway layer. These state charts define a finite number of valid configurations, precluding any non-deterministic behavior during runtime execution phases. When an agent completes a specific subtask, the gateway evaluates the output against defined state transitions. If the output meets compliance metrics, the transaction moves smoothly to the next agent. If the evaluation fails, the gateway initiates automated remediation protocols rather than allowing a loop. This proactive error handling isolates the faulty node and preserves the overarching system integrity immediately. This deterministic design completely transforms how multi-agent workflows are managed at scale. It provides enterprise technology leaders with the precise tools required to deploy autonomous systems with absolute operational confidence. The empirical evidence documented remains completely undeniable. Structured orchestration frameworks consistently outperform ad hoc routing methods across every critical performance index and operational metric evaluated. Embracing this architecture allows your company to build highly secure, infinitely scalable AI applications. You can confidently expand your automation capabilities without risking infrastructure stability or inflating operational cloud expenditures. Ensure your engineering teams are thoroughly trained in event-driven design patterns and state chart modeling. Investing in these technical skills is crucial for accelerating your organization's digital transformation journey successfully. The architectural blueprints analyzed today provide a definitive roadmap for modern corporate technology deployments. By building stateful orchestration gateways, you secure a lasting competitive advantage in the global marketplace. Take the next step in your professional development by mastering these advanced infrastructure concepts today. Building resilient, future-proof enterprise systems requires a deep commitment to architectural excellence and continuous learning. Stop guessing your tech strategy and wasting your time. Subscribe to our Enterprise Tech Brief right now. We deliver zero hype, pure architecture. Master enterprise AI, cloud transformation, and cybersecurity completely free. Hit the subscribe button